Welcome to the lecture 3 in the series on web-based technologies and multimedia applications. In today's lecture, we will be discussing about internet addressing. The objective of this lecture is to discuss about various addressing schemes of the internet. In internet, we always have two types of computers. One are servers, the second are clients. A server is a computer with the capacity to provide connectivity and sharing to multiple personal computers or clients, which is specifically set up to serve its files to client computers. The files that a server makes available to your computer can be web pages, videos, sounds, images, and any other content. For a home computer to be able to receive files or any data from a server, the home computer must request for the information. This happens when we enter a URL in our browser and when we receive the email. Whenever we need information, we always enter the website address, which I just quoted as URL. Based on that address, the communication channels will get the information from that particular location and they will load onto our machine, which we will be able to see in our browser. When we work on internet, we come across different types of addresses used for different purposes like web address, IP address, email address. For example, IP address stands for Internet Protocol Address. This is one very important concept which we will be dwelling in detail in today's discussion on internet addressing schemes. Each one has a special syntax and meaning. It is important for you to know about these addresses before we start working on internet. The reason why I said that each one is having a special syntax is that only based on that syntax, the correspondence will be made with other elements on other networks. For example, two humans when they communicate, there is grammar in the language they speak. Based on the grammar, the meaning may also change. The same is the case with communications between networks also. So when one is communicating with another, the protocols and other things are having a specific syntax, specific format. If that format is not followed, there are chances of miscommunication or even some errors coming up while you communicate. So syntax is very important when communication between various networks is taking place. Let us see what is a web address. An internet or a web address, sometimes we also call it as a URL. URL stands for Uniform Resource Locator, and it is composed of 4 parts. They are a protocol name, and as I already told you in earlier presentations, a protocol is nothing but it is a set of rules and standards that enable computers to exchange information. Then the location of the site, then the name of the organization that maintains the site. A suffix that identifies the kind of organization it is, such as .com for a commercial organization. Every day whenever we are browsing, we always enter address in the URL, and that particular URL, when it is decomposed, then we get these 4 parts, and based on the information given in each part, the correspondence will be taking place across the internet between various networks, and ultimately we get the output which is printed on our browser or loaded on our browser. For example, let us consider the website address http://www.ignou.ac.in. In this, HTTP is the web server that uses hypertext transfer protocol. www is the site on the World Wide Web. Then IGNOU, it is the web server at IGNOU, and AC, it means that this particular address corresponding to an academic institution. Then IN means it belongs to India. So this is how when we decompose the website address, we get all this information. When we are viewing a web page, the page's address appears in the address bar in Internet Explorer or any other browser which we use. Hosts, that is users, and local networks are grouped together into domains, which are grouped into one or more larger domains. For an analogy, a host computer is considered as an apartment building in a housing complex, and your account is just an apartment in it. Domain may be an apartment complex, a town, or even a country. Subdomains may correspond to organizations such as NASA or CompuServe. Domains are classified as non-geographic and geographic lists various common domain names. The domain names in India come under a larger domain in. So whenever something is prefixed with a .in, it means that that particular website address belongs to an Indian company. Now let us see some non-geographic domains. For example, .com, it doesn't indicate any country, but it indicates that that organization is commercial in nature. Now let us see .net. .net means network organizations. Then .gov, it means that that particular organization is part of government. Then .ac, these are the organizations of higher education. Then .mil, it means that these are non-classified military networks. .org, these are organizations that do not fit the commercial or educational designations. So based on the domain of the organization or domain of its functioning, a suffix will be given. Sometimes it so happens that the suffix represents the country but not the nature of the organization. Sometimes the suffix represents the nature of the organization but not the country. For example, let us consider oracle.com. So we don't know whether this particular organization is a commercial or a network or part of government and what it is. But from .com, we can conclude that it is a commercial organization. But at the same time, we do not know to which country this belongs to. So Oracle is based in USA, but that information you will not get on looking at the website address. So sometimes you get the information about the country and sometimes we get the information about the nature of the business or nature of the organization. Now there are geographic domains also. Here Australian organizations are suffixed with .eau, Chinese organizations with .cn, German organizations with .de, Japanese organizations with .jp, Indian organizations with .in, UK organizations with .uk, and USA organizations with .us. Similarly, many countries are having their own geographic domains on the internet addresses. So once a person looks at the suffix, he knows that this is something from Australia. So sometimes you can even guess the language looking at the suffix. Okay, this particular page may not load in English, it may load in their local language. There are chances, okay, but it is not essential. But definitely what we will be able to know is that this particular organization's geography, that is from where this organization is coming. Now let us consider IP address. IP address, as I already told you, it stands for Internet Protocol Address. So the internet layer, it is an important layer in the protocol suite. At this layer, TCP/IP supports Internet Protocol. This layer is responsible for the format of datagrams as defined by IP and routing and forwarding a datagram or packet to the next hop. Hop means it is a term that can be used to represent any computing device on internet. For example, router, gateway, computer, all these are computing devices on the internet. The primary goal of the internet is to provide an abstract view of the complexities involved in it. Internet must appear as single network of computers. At the same time, network administrators or users must be free to choose hardware or various internetworking technologies like Ethernet, token ring, etc. Different networking technologies have different physical addressing mechanisms. Therefore, identifying a computer on the internet is a challenge. To have uniform addressing for computers over the internet, IP defines an IP address, which is a logical address. IP address is a 32-bit number and it can be represented in decimal. For example, of an IP address, let us see something like this: 192.168.32.10. This is an IP address. It can be represented using 32 bits. Now, when a computer wants to communicate to another computer on the internet, it can use a logical address and is not bothered with the physical address of the destination, and hence the format and the size of the data packet. Basically, in computers, we all know that we write programs. A program is nothing but it is something, a logical entity. It is going to be converted, and ultimately it is the machine language which is going to be executed on your computer. Since we cannot write using machine language so easily, we write using a programming language which is in English-like language and which is very easier for us to write. The same is the case here also. Here the IP address is a logical address, and then there will be several mapping schemes wherein this IP address is mapped, and routing tables, all those things will come into the picture, and ultimately wherever that particular computer is there in this world connected to the internet, the information will be fetched from there and will be provided to your browser on your computer. So since we are dealing with a logical address, there is no need for us to worry about the physical address of the destination, as well as the format of the data packet, as well as the size of the data packet. IP address is a basic address used by the lower architecture of the internet. It is important for us to know that any address we type as web address or email address actually gets converted into the equivalent IP address of a machine or computer where the server or resource is available. Web address or email addresses are used for easiness of human beings. Otherwise, it is just a burden for the network. Suppose we are able to directly type the IP address in the browser, then lot of work will be reduced for the processor. But if we are typing an address, a website address such as oracle.com or ignou.ac.in or any other address, again it is going to be converted into IP address. So definitely there is a delay there. If you directly type the IP address, then it directly works on the mapping and gets the information faster. But we cannot remember IP addresses for every entity so easily because they are numbers, that's it, and remembering them will be very difficult. So it is for us very convenient that if there is a company called Oracle, okay, most probably its website address is oracle.com. So if it is not oracle.com, just type it in the Google, you will get the address and click on it, you are going to their site. But working with IP addresses individually is very, very complicated, and you just can't remember the IP addresses of even those organizations which you will be visiting almost every day on your internet. So IP address makes our life very, very easy, but then a bit of delay is added or a bit of overhead is created in processing to the internet. An IP address, it is a numerical label assigned to each device connected to a computer network that uses the internet protocol for communication. An IP address serves two main functions: host or network's interface identification and location addressing. So these are the things which this IP address will be doing, and these are the two main functions. And in this context, I would like to introduce you what is called IPv4, that is Internet Protocol version 4. It defines an IP address as a 32-bit number. However, because of the growth of internet and the depletion of available IPv4 addresses, a new version of IP is coming up, which is called IPv6, and it uses 128 bits for the IP address. and it was standardized in 1998. So it's already in place. IPv6 deployment has been ongoing since mid 2000. So it's widely used internet protocol now. IP addresses are written and displayed in human readable notations such as 172.16.254.1 in IPv4 and let me say 2001 colon DB8 colon 0 colon 1234 colon 0 colon 567 colon 8 colon 1 in IPv6. So you can't remember these addresses. So for us, okay, something like an oracle.com, something like an IGNOU.ac.in, these things we will remember, and its conversion we are not concerned at all. Let it be converted into an IP address conforming to IPv6 or IPv4, it doesn't matter, and we just remember only the names so that it is easily for us to remember, and it is also easy for us to remember many such addresses. The size of the routing prefix of the address is designated in CIDR. CIDR means classless interdomain routing, and it is the notation by suffixing the address with the number of significant bits. For example, 192.168.1.15/24, which is equivalent to the historically used subnet mask 255.255.255.0. The IP address space is managed globally by the Internet Assigned Numbers Authority, that is IANA, and by 5 regional internet registries, RIRs, responsible in their designated territories for assignment to local internet registries, such as internet service providers and other end users. IPv4 addresses were distributed by IANA to the RIRs in blocks of approximately 17 million addresses each. 17 million is approximate, okay? There will be an exact number, but have been exhausted at the INA level since 2011. Some IPv4 addresses are reserved for private networks and are not globally unique. So the addresses that are reserved for private networks, they cannot be assigned to anybody, okay? And also they are not unique numbers at a global level. Network administrators, they assign an IP address to each device connected to a network. Such assignments may be on a static, that is fixed, or permanent, or dynamic basis, depending on the network practices and software features. So you can have a static IP address, you can also have a dynamic IP address. An IP address serves two principal functions. It defines the host, or more specifically, its network interface, and it provides the location of the host in the network, and thus the capability of establishing a path to that host. A name indicates what we seek, an address indicates where it is, a route indicates how to get there. So all the three things are given, and ultimately it will be able to reach the destination, get the information, and load them into your browser. So one very important thing is, if you are on a network, your device is having an IP address. So you must be having a doubt that your mobile is there. You switched on the mobile data and started accessing the internet. Now, does your mobile device having an IP address? Just find out. This is an assignment to you. And if yes, what is its IP address? And once you found its IP address, if at all it is existing, then is it a static IP address or is it a dynamic IP address? What are the advantages of static IP addresses? What are the advantages of dynamic IP addresses? You have to explore and you have to write answers. And this is for you. If possible, drop an email to me at the given address, which I will be showing you on the slide as during the conclusion portion of this particular presentation. The header of each IP packet contains the IP address of the sending host and that of the destination host. Earlier, I explained you what is meant by a packet. Basically, whenever information is being transmitted or received across the networks, information is sent in terms of bits, but those bits are put inside a packet, and in fact, I have to say that all bits are divided into packets and these packets are sent. It's like you're sending a lot of luggage to some other place. So basically you pack them. So when you pack them, you have a suitcase, then you have a bag. So all these are packets. One important thing is that the size of each packet need not be uniform, just like in the real life. Each packet may have its own different size, but the only difference between the real life and the way things work on the internet is that in real life, all the packets take the same route to reach the destination. But in the case of internet, these packets may take different routes, but once they reach the destination, they are opened in the same sequence in which they are supposed to be opened, as the necessary information is provided in each packet in the form of headers. Two versions of the Internet protocol are in common use in Internet today. The original version of the Internet protocol that was first deployed in 1983 in the ARPANET. The predecessor of the Internet is Internet Protocol version 4. The rapid exhaustion of IPv4 address space available for assignment to Internet service providers and end user organizations by the early 1990s prompted the Internet Engineering Task Force to explore the new technologies to expand the addressing capability in the Internet. The result was a redesign of the Internet Protocol, which became eventually known as Internet Protocol version 6 in 1995. IPv6 technology was in various testing stages until the mid 2000s, when commercial production deployment started. Today, these two versions of Internet Protocol are in simultaneous use. Among other technical challenges, each version defines the format of addresses differently. Because of the historical prevalence of IPv4, the generic term IP address typically still refers to the addresses defined by IPv4. The gap in version sequence between IPv4 and IPv6 resulted from the assignment of version 5 to the experimental Internet Stream Protocol in 1979, which however was never referred to as IPv5. Other versions from version 1 to version 9 were defined, but only version 4 and version 6 ever gained widespread use. Version 1 and version 2 were names for TCP protocols in 1974 and 1977, and there was two separate IP specification at that time. V3 was defined in 1978, that is version 3, and version 3.1 is the first version where transmission control protocol is separated from Internet protocol. Version 6 is a synthesis of several suggested versions. IP networks may be divided into subnetworks in both IPv4 and IPv6. For this purpose, an IP address is recognized as consisting of two parts: the network prefix in the higher order bits and the remaining bits called the rest field, host identifier or interface identifier like IPv6, used for host numbering within a network. The subnet mask or CIDR notation determines how the IP address is divided into network and host parts. The term subnet mask is only used within IPv4. Both IP versions, however, use the CIDR concept and notation. In this, the IP address is followed by a slash and the number in decimal, and these number of bits used for the network part also called the routing prefix. For example, an IPv4 address and its subnet task may be 192.0.2.1 and 255.255.255.0 respectively. The CIDR notation for the same IP address and subnet is 192.02.1/24 because the first 24 bits of the IP address indicate the network and the subnet. An IPv4 address has a size of 32 bits, which limits the address space to 2 power 32 addresses. Of this number, some addresses are reserved for special purposes such as private networks. Of this number, some addresses are reserved not only for private networks but also for multicast addressing. IPv4 addresses are usually represented in dot decimal notation consisting of 4 decimal numbers, each ranging from 0 to 255, separated by dots. For example, 172.16.254.1 Each part represents a group of 8 bits, an octet of the address. In the early stages of the development of the Internet protocol, the network number was always the highest order octet, most significant 8 bits. Because this method allowed for only 256 networks, it soon proved inadequate as additional networks developed that were independent of the existing networks already designated by a network number. In 1981, the addressing specification was revised with the introduction of classful network architecture. Classful network design allowed for a larger number of individual network assignments and fine-grained subnetwork design. The first 3 bits of the most significant octet of an IP address were defined as the class of the address. 3 classes A, B and C were defined for universal unicast addressing. Depending on the class derived, the network identification was based on octet boundary segments of the entire address. Each class used successively additional octets in the network identifier, thus reducing the possible number of hosts in the higher order classes, such as B and C. The following table, for example, let us now take a small overview of this particular system. Actually, this is now obsolete and nobody is using it. Classful network design served its purpose in the startup stage of the internet, but it lacked scalability in the face of the rapid expansion of networking in the 1990s. In IPv6, the address size was increased from 32 bits in IPv4 to 128 bits, thus providing up to 2 power 128 addresses. This is deemed sufficient for the foreseeable future. The intent of the new design was not to provide just a sufficient quantity of addresses, but also redesign routing in the internet by allowing more efficient aggregation of subnetwork routing prefixes. This resulted in slower growth of routing tables in routers. IP addresses are assigned to a host either dynamically as they can join the network or persistently by configuration of the host hardware or software. Persistent configuration is also known as using a static IP address. In contrast, when a computer's IP address is assigned each time it restarts, this is known as using a dynamic IP address. Dynamic IP addresses are assigned by network using dynamic host configuration protocol. Now, let us see about the email address. Until now, we have seen the website address or a URL. Now, let us consider email address. Earlier also we studied that email is one of the popular services used by the people on the internet in the daily life. Now, a typical email address can be something like username @subdomain.domain. And this is the format adopted by all the email service providers such as Gmail, Rediff, Yahoo, MSN, or even any other network domain name. The username in general is the name assigned or chosen during creation of an email account. Subdomain or domains we have already discussed in above section. In case of private service providers, it is generally its own name like abc@yahoo.com, abc@yahoo.co.in, abc@gmail.com. In the domain names, it is essential to have non-geographic domain name. However, sometimes we can see both kind of domains which are non-geographic as well as geographic. So let's take an example to better understand this email address. For example, in the email address pvsuresh@ignou.ac.in, pvsuresh indicates the username. The subdomain is named IGNOU, which is an academic organization. That's why it is .ac and is situated in the country India. That's the reason why we have .in. So this is the interpretation of pvsuresh@ignou.ac.in. So this is what I would like to tell you in today's session, and I have also given you some references. You can always browse to those sites to get more and more information. So I thank you all for attending today's presentation, and in case you have any doubts, please feel free to email to me. Thanks a lot.